Alright everybody, welcome back to another video. In this lesson, we're going to be covering how to set up your own simple WebSocket server using Golang, and in the next part, we'll be covering how to connect to that server using Godot. So this will be a little bit of a shorter part because we're just going to be working with code on the server side. At the end of the last lesson, we finished installing the necessary tools and demonstrating how to work with our packet system. If you want to download the code to get you up to speed to follow along with this lesson, you can visit the official GitHub repository. Link will be in the description. And then you can just come down here to the releases section and just click on version 0.01. So this will represent the state of the project at the end of the first lesson. So you can just come here and download this little zip folder here, and you can unzip that somewhere and open that with your VS Code or what have you. So today we're going to be following along with lesson number 2 from the blog posts. So again, you can always come to my website tbat.me and then click on the projects section, Godot Golang tutorial series. And today we're going to be following along with this post here. So all of the code that you'll want to copy and paste from is going to be located in this post. Without further ado, let's open up VS Code. Make sure we've opened up our project directory, and let's get started. So for this project, we're going to be choosing to work with WebSockets, which are a really great choice for us if we want our code to be cross-platform and flexible enough that we don't really need to worry too much about the game engine that we use. So in this lesson, we are using Godot, but if you wanted to use a different game engine like Unity or GameMaker, you can also apply these concepts that you've learned in this series to those game engines as well. So that's the reason that we're not using Godot's own server-side networking framework. This is just a lot more flexible, and it's also a little bit more applicable to the real world. So WebSockets are a TCP-based connection. So they are maybe not a great choice for like a fast-paced real-time action game, but they're pretty good for something like a small turn-based MMO or some sort of RPG online game. And even for our use case, the semi-fast-paced game that we're making, because it is so simple, WebSockets are also more than capable of doing what we need. So that being said, we're going to be creating a WebSocket server today using Go, which is actually a lot more simple than you might think. Go already has a lot of inbuilt functionality to make a HTTP server, and you can extend that using a clever library called Gorilla WebSockets, which basically upgrades the HTTP connection to a WebSockets one. Before we get into any of that, we'll discuss the architecture. So we're going to be going with a hub and spoke model where we're going to have a central hub which listens to all of the incoming connections. And when your client connects to the hub, it will dispatch your connection to a client interfacer, which is going to be responsible for handling all of your requests and maybe communicating those back to the hub if necessary. But basically it's like your own personal extension of the hub. And there will be multiple of these client interfaces, all working in parallel to process your game requests and turn them into data that the client is going to be able to use to interpret the game world. So one of the great features of Golang is its concurrency model. These different client interfaces are all going to work in separate Go routines, which is Go's version of like a very lightweight thread, which is very, very easy to work with. And they're going to be communicating over channels, which are just a way to connect separate processes without having to worry about locking or shared resources or anything like that. So in this diagram, you can see in the middle is the hub, and on the very left-hand side, we've got the client. The client is connecting to a WebSocket, which gets passed to the hub. And then the hub is creating these client interfaces, which continuously interface with the WebSocket connection. So let's get started creating the hub. We're going to create a new folder inside our server folder called internal. And then we're just going to create a new folder inside internal, also called server. So this is where all of our server-specific logic is going to live. And then we're going to create a new file under server called hub.go. So this is going to belong to the server package. And we're just going to import a few things that we're going to need for setting up this basic server. So we're going to need to log things, this is a good package for managing logging. Like I mentioned before, we're going to set this up as it were a HTTP server, and we'll upgrade the connection later. And this is the same packets package that we created in the last video. So the hub's going to be a pretty simple struct. It's going to contain a map of client interfaces, which is something we haven't defined yet, but it's what I was talking about. These are the spokes in our hub and spoke model. It's going to contain a map that maps IDs to instances of client interfacer. So let's go ahead and get that laid out. This map is just going to be called clients. And this is eventually going to be an interface. So let's go ahead and just put a little stub for that, just to satisfy the error message. We're also going to have a broadcast channel, which we're going to put packets into, and clients will be able to put packets into this channel as well. And the intention is that it's going to broadcast every packet that's in this channel to all of the other client interfaces. So this is going to be our broadcast channel. And the idea is if a client puts a packet into this channel, the hub is going to dispatch that packet to every other client interfacer as a way to just get the message across. So if I put a chat packet inside the broadcast channel, I can know that it's going to be interpreted by every other client in the game. So this is a broadcast channel. It's just going to hold references to packets. We're also going to need a channel for clients who want to register with the hub. So when you create a new WebSocket connection, it's going to spawn a new client interfacer, and that client interfacer is going to want to register with the hub. So let's go ahead and make a register channel. And this channel is just going to hold pointers to client interfaces themselves. And similarly, we're going to have an unregistered channel. So that's all of the data that the hub is actually going to need to operate. So it's fairly simple. Let's just create a quick constructor for the hub. So new hub, going to return a pointer to a hub object. And let's just go ahead and let Copilot take over there. So it's just making a new empty map of IDs to client interfaces. And then it's just making empty maps of packets and client interfaces for all of the channels respectively. So let's go ahead and create a run method for our hub. So the run method is essentially just going to be listening on all of the different channels. So if it receives a client interfacer on the register channel, it will go ahead and initialize that client. If it receives something on the unregistered channel, it'll go ahead and remove that client from our map. And if it receives a packet in the broadcast channel, it'll go ahead and tell all of the clients to process that packet. And we can also do some logging here. So you can use log.println awaiting client registrations. We're going to use a select loop here and look at all the different cases. So this is essentially just going to always be waiting for things to come in on the various channels. And if something is coming in on 2 channels at once, it'll just choose one of them. It'll just be a very nice flow for the hub to run and listen to all of these things. So as I said, if we get something on the register channel, we're going to initialize that client. This is a method that doesn't exist yet, but we can define it in our client interface. So what should the initialize method do? It should probably take an ID number. And the idea is it's just going to go ahead and initialize everything. What's the ID that we should give the client? Well, for now, let's just go with the length of the client's map. And alarm bells might be ringing if you are thinking about concurrency and locking, but let's just go ahead with this naive approach for now, and we'll see what happens. But essentially, the ID of the client is going to be like, at first, the ID will be 0, and then the next client that connects, it'll be 1, and then 2, and so on. As the client map grows in length, each client will get the next consecutive integer as their ID. So if we get someone coming through on the unregistered channel, we're just going to simply remove them from the map. And we can't really just delete them from the map though, because that will make the next client's ID get reused. So we'll just set them to nil. And finally, if we get a packet in the broadcast channel, we're going to go ahead and loop through every client in our map. We're going to say if the ID is not equal to the packet's sender, then we'll just go ahead and send that packet. Let's see, Copilot here is saying send packet, but I'm going to go with process message. We're also going to pass in the sender ID, and we're going to pass in the actual message that's inside the packet. So we're going to break down the packet a little bit before we give it to the client. So we are going to need to define a couple new methods on the client interfacer. So let's go ahead and add an ID method. So this one should be pretty self-explanatory. It's just going to return the ID of the client. And we're also talking about a process message, which is going to take in a sender ID, and it's also going to take in a message. Okay, so far we have our hub's run method, which is looking pretty good. And we've defined a few things that we're going to need in our client interfacer. Let's go ahead and create a method that's going to actually serve a WebSocket connection to a client. This is going to be a method on the hub, and we're going to call it serve. And because the hub is pretty agnostic to the actual implementation of your server, so it doesn't actually care if it's a WebSocket server or not, you could create your own TCP server and still use the code in this hub.go file. We're going to keep things pretty general, and the first argument for the serve method is actually going to be a handler that we can pass in, sort of like the WebSockets handler, into this method. So we're just going to call this get new client, and it's actually going to be a function itself that takes a reference to the hub, an HTTP response writer, and a HTTP request. And this handler method is going to return a client interfacer and also an error, potentially. So this is the first argument. And this will become more clear once we start actually creating the connections and then sending them to the hub. And the second argument to this serve function is just going to be a HTTP writer. And the final argument is just going to be a HTTP request. If this method gets called, it means that we have a new connection from a WebSocket connection, or any kind of connection really. But in our case, it will be a WebSocket connection. So we can log that we have a new client connecting. We can actually get the remote address of the connecting client. And we're just going to create a new client interfacer like this. Use the handler method and pass in the writer and the request that we're getting on the serve function. We'll just do a quick check for an error. We can print the error like this. And we just return from this serve function if we do hit an error. But if we don't get an error, we can register this client with the hub. Each client interfacer is going to need to continuously read from the WebSocket connection and write to the WebSocket connection. And the power of Go and its concurrency model is we can easily do these things in a background thread. So we can just write Go. This is a special keyword that means do whatever I write next in its own background thread. So we're going to have something called a write pump, which is just going to be a loop that continuously writes to the WebSocket connection. And we're also going to run the client's read pump, which will read from the WebSocket connection. So these things don't exist yet, so let's go back up to our client interfacer interface, and we can sketch those out. All right, so now we've sketched out those methods that's going to be required for any client interfacer. And I'm just seeing we have a little warning here. It looks like I wrote print line instead of print F. So let's go ahead and get that fixed up. And now we have no errors in our file. So there's a few things that our client interfacer is going to be capable of doing, but there's just a few more things that I think every client interfacer should be able to do. Like, for example, it would be nice if there was some easy way to put a packet into the right pump. So let's go ahead and make a method for that. And we're just going to call this socket send. So this is, if we call this method on a client interfacer, it's going to tell it to just send a packet straight to the client. So basically express shipping straight to Godot 4. And we might actually want to send a message to the client, but as a different sender. So this could be useful for just forwarding a message from a different client interfacer, which might have been received on the broadcast channel. And if it maybe was like a chat message from a different player, you want to send it as that player. So let's go ahead and make that. So puts data from another client into the right pump. So we'll just call this socket send as. And it will also take a message as its first argument, but it will also take a sender ID as the second argument. Let's also sketch out a method for forwarding a message to a different client for them to process. So this might be useful for maybe sending like a DM to a different client or something like that. You can send like a chat message, and then you can put yourself as the sender. And finally, second last, every client is going to need a way to put packets into the broadcast channel easily. So let's go ahead and make a broadcast method. And finally, let's make a way to close the connection and clean up any other resources that need to be cleaned up on the client interfacer. We can also give a reason in this close method, because this might be useful for logging, or it might be also useful for sending that information to different clients. So that's it for our hub.go file for now. We've laid out the foundation of a client interfacer, which we will be able to implement in the form of a WebSocket client. We've also got a basic hub model down, which just contains a map of these different client interfaces and various channels for doing different things, which we do down here. This is just record keeping, and this is actually broadcasting packets to be processed by each client interfacer. And we've also got a way to start serving these requests as they come in and continuously running the read pump and the write pump for each client. So we can go ahead and save our hub.go file. And let's actually go ahead and create a WebSocket client now. So before we get into that, we're going to be installing the Gorilla WebSocket package, which seems to be the most popular package for working with WebSockets in Go, and it can just upgrade your HTTP connection pretty easily with just like one line of code. So we're going to install that here by going into our terminal. We're going to change directory into our server directory, and then we're just going to run go get github.com/gorilla/WebSocket. So we're going to go ahead and create a new folder inside the server folder. So it should be under server, internal, and then server again. New folder. We're going to go ahead and call this clients. So this is where we're going to keep all of our client interfacer implementations. For this series, we're only going to have the one, which is going to be the WebSocketClient implementation. But again, if you wanted to create your own custom TCP implementation of this client interfacer interface, you can go ahead and do that as well. So I'm just going to create a new file in here called WebSocket.go. And we're just going to say that this file belongs to the clients package. So we're going to import a few things that we're going to need. We're going to need to log stuff, as well as we're going to need this HTTP package again. We're also going to need access to the server so that we can reference the hub. So server/internal/server. We're going to need access to our packets package. And we're also going to need Gorilla WebSockets and protobuf. So let's go ahead and lay out our struct for the WebSocket client. So all a WebSocket client's going to need is an ID. It's going to need the actual WebSocket connection itself. It's going to need a reference to the hub. It's going to need a send channel. And we'll also give it a logger. So we're going to create a custom logger for this WebSocket client. And as I save this file, it's just sort of dynamically getting rid of all the imports that I typed at the beginning. So maybe I shouldn't have typed them all, but yeah, you can kind of like not worry about writing your imports at the beginning, and then you can just start typing and it'll probably just add those imports for you. So with that aside, let's go ahead and create a constructor for our new WebSocket client. So looks like Copilot sort of has it right. We definitely want a WebSocket connection, but let's actually put the hub as the first argument. We'll put our HTTP writer as the second argument, and we'll put a HTTP request as the third argument. So you might notice that the signature of this constructor matches the signature of the handler that we are using in the hub.serve method. So this get new client signature here actually matches the signature of our new WebSocket client. So every time if you want to make your own client interfacer implementation, the constructor should match this signature. We're going to be passing this constructor in when we actually accept a new WebSocket connection and then pass it to the hub. So we'll be doing that in a separate file. But for now, we're just going to define the upgrader for the Gorilla WebSockets library to upgrade our HTTP connection to our WebSockets one. So we're just saying that the read buffer and write buffer are going to be about 1024 bytes in size, and the check origin function is just going to always return true. So this just means that the origin is always going to be acceptable. So no matter who's connecting, we're just going to accept everyone. But you can put in your own custom logic here based on the request parameters. So if you want to like ban someone, like if you want to ban someone by their IP address, you can put a custom check origin in here to just return false if you see that person's IP address. But we're not going to worry about anything like that in this series. And there's probably better ways to do that as well. So yeah, this is where we're actually going to upgrade our connection to a WebSockets one. So now our connection is a pointer to a WebSocket connection. I'm just going to check for errors here. So if we do get an error, we're going to return nil as the client interfacer, and we're going to return error as the error. Now we're actually going to create our WebSocket client. So the send channel, we want to be a buffered channel so that it doesn't clog up every time something is awaiting to be sent. So we can allow it to store 256 packets at once before it starts blocking. So let's go ahead and make a buffered channel of pointers to packets with 256 capacity. We're going to create a new custom logger here. And since we don't know the ID of the client yet, we're just going to put client unknown as the prefix for the logger. And we're just going to use the standard flags. So it's going to include like the date and time, and it's going to include like the message and all of that. So yeah, it's going to have this prefix, and then it's going to have the date and the time, and then it's going to have whatever we're going to log. And then at the end of all that, let's just return our new client interfacer. And we're getting an error here because it's saying that our WebSocket client does not implement the server's client interfacer. So we're missing all of the methods, but it's saying that we're specifically missing the broadcast method. But we're going to go ahead and implement all of those methods to satisfy this error. So let's start with the ID method. We'll get that one out of the way pretty easily. I probably don't need to explain this one, so I'm going to go ahead and let's see what else is on our checklist. We can always come back to this error and see what we're missing, or we could check with our hub.go file. I'm actually going to put that over here. so we can just work down the list. So we're going to do the process method function next. And we're just going to leave that blank for now. Let's do the initialize method. So we're just going to set the ID of our client equal to the incoming ID. So now we're going to be using c.logger, which is our custom logger. It'll just make the output look a lot more organized, especially when we have multiple clients connected. We're actually going to set the prefix now that we know our ID. And let's just use like a formatted string here. sprintf client, and then the number's going to go there. And we're going to use c.id, or I guess just ID. Doesn't really matter. And we'll just press Ctrl S so it will import the format package for us. There we go. Now let's do the socket send method. So this one's going to be pretty simple. We're actually not going to implement the logic in this method. We're going to pass that on to the socket send as method. So let's just go ahead and do c.socket send as. And we're going to send it as ourselves. So what's socket send as going to look like? So we're basically just going to say if there is something available on the send channel, if it's ready, we're going to stuff our sender ID and our message inside a packet struct, and we're going to put that into the send channel. But if the send channel is not ready, if it's full, we're just going to drop the message. And we're just going to log something. So this is if there's already 256 other packets waiting to be sent. Cool, so we have a way to send a message to our WebSocket connection from someone else. And just by virtue of the fact, we get this method for free because we're just passing in our own ID. All right, let's implement the next method here. This is going to be the one that forwards the message to another client. And this one's going to be pretty simple. We're going to just quickly grab the client from the hub's map. So we're going to pass in the peer ID. So Copilot's screwing me over. I'm just going to call this the peer ID. So yeah, this line here in the client interfacer should have said peer ID as the final argument. The sender ID is going to be us, and the peer ID is the person that we want to forward our message to. So we're just going to check to see if this peer ID is a registered client. We're going to tell them to go ahead and process our message. So the process message, the first argument is the sender ID, so that's going to be us. And then we give it the message that we want to pass along. Let's go ahead and do the broadcast method. This one's going to be pretty simple. We're just going to be using the hub's broadcast channel and sticking our packet inside. And let's see. We've just got to do the read pump and the write pump now, and then the close method. So this one's going to be a fairly long function because it's responsible for interfacing directly with the WebSocket connection and reading messages from that WebSocket and processing them. So this is where we actually need to turn the raw data into protobuf packets, sort of like what we were doing at the end of the last video, and doing logic on that. So first things first, let's go ahead and make sure we close the read pump at the end of this method. Even if we get a error, we want to make sure we always clean up the connection if we get to the end of this method. So this is going to be an infinite loop, but yeah, if we do get to the end of it, we just want to make sure we clean up. So we can use the defer keyword for that. And we're going to defer, we're going to make sure a couple of things get run. We're going to log a message. And then we're just going to close the client. So this is actually a method we haven't written yet, but we're going to go ahead and call it anyway. That's going to be this one, so we'll give it a reason, and we'll just say read pump closed. And then we go ahead and put a stub for that method, just to satisfy the IDE. So first things first, we defer cleanup, but now we're going to start listening on the read connection. So we're just going to have an infinite loop. We're going to go grab data from the WebSocket connection. We're going to check for errors. So we're just going to see if this was like an expected error, like for example, if the client quit and we can't read a message from them anymore. We're not necessarily going to log that as an error because it's pretty standard stuff. So we're only going to log something if we see something unexpected. So we can check on this error if WebSocket.isUnexpected close error. And here's where we're going to actually put in the list of errors that we do expect. So we've got like close going away. That's pretty expected. And we've also got close abnormal closure. Even though it has the word abnormal in the name, this is also something that we would expect. So we'll just go ahead and print out that error if we see it. And otherwise, well, regardless, we're going to break out of the loop, which is going to go and make sure that everything gets cleaned up. So now if we've made it this far in the loop, we've got some acceptable data, which is a slice of bytes. And if you watch the end of the last video, we already know what to do with that. We're going to go create an empty packet, and then we're going to unmarshal that packet. I've called it packets. There we go. Check for errors when we're unmarshaling the data into a packet. And if we get an error, then we're just going to continue and try to read the next packet. So we just won't worry about it. We're going to go ahead and add like a nice quality of life feature. So basically, we're going to make it so that if the sender ID was 0, we're going to assume it came from our own client. So when you're on the Godot side of things, there's only one person it's going to come from. It's going to be coming from yourself. Godot has no way of sending a packet as another person, nor should they. We're just always going to send a sender ID of 0 from the client side of things, and we're going to be able to correctly interpret that on our WebSocket client interfacer by just checking if packet.senderID equals 0, then we're just going to set it equal to the client's ID. And finally, we're just going to go ahead and tell our client interfacer to process this message. Okay, so that's it for our read pump. We're simply just reading messages, doing some error handling, unmarshaling the packet, and then processing that packet. So it looks like it's a lot, but it's not actually doing a whole lot of things. Then we can go ahead and similarly implement our write pump, which is just going to continuously listen to the send channel and then pump those messages to the WebSocket connection. So we're going to do another deferred function. And we're just going to do the same thing. So here's where we're actually going to listen for packets coming in on the send channel. We're going to get a writer from our WebSocket connection, and we're going to make sure it's a binary message writer because we're using protocol buffers, and we're going to be putting binary objects, i.e. our packets, inside this writer. So we're just going to say if there was an error getting the writer, we're just going to print out something to the log, and we're just going to return from this method. Because unfortunately, if we can't grab a writer, then there's nothing we can really do. So now we're going to go ahead and marshal our packet into data bytes that we can actually send. And I've put an S at the end of packet here again. So this should just be for packet in range from the send channel. We're just going to check for errors marshalling that data as well. And just fix up these typos. Okay, all good. And in this instance, we're just going to continue in the loop because maybe it was just this packet that was bad. So we're just going to ignore the rest of this instance of the loop, but we'll try again next time we go around. And then we're just going to try to write the data to our writer. And if we get an error, then of course we're also going to do some logging, and we're just going to continue in the loop. And here we're just going to, after we've written our data, we're just going to write a new line just to make sure that packets don't sort of stick to each other if you're sending multiple packets in rapid succession. It's always good to just sort of like flush the writer with a new line just to make it very clear that these are separate. And let's go ahead and close the writer now. So, and we've gone ahead and closed that writer off now. And if we got an error, then we'll just log it out and continue. So this is it for the write pump. It's pretty simple. It's just most of it is error handling and cleanup. So we're essentially just listening for packets on the send channel. When we get one, we're going to open up a new writer. We're going to marshal our packet into data. Then we're going to write the data to the writer, flush it, and then close the writer. And finally, we can just go ahead and finish things off by implementing our close method. We can include the reason in our log. Now we're just going to go ahead and unregister ourselves from the hub, close our WebSockets connection, and we're just going to go ahead and close our sender channel if it's not already closed. So we'll just do a quick check. So we can actually just try to read from the send channel, and if we get an error, then we know that it's going to be closed. So we want to make sure it's not closed, and if not, then we'll just close it. All right. So we've successfully gone ahead and implemented everything we needed to implement. I've just got one warning here, which is probably because I need to write that as a printf instead of a print line. And yeah, we've successfully gone ahead and implemented a WebSocket client, which implements our client interfacer, which means that we can actually go ahead and pass it into the Hub's serve method. So we can use the constructor of our WebSocket client as the handler in the Hub's serve method. So where are we going to do all of this? Well, we're going to do it in the main.go file that we created in the last video. So whatever we have in here, we're just going to get rid of, except for the package main. And we're actually just going to create a variable for the port. So we're going to take a command line argument, which is going to be an integer, and this is going to be the port that we want the server to listen on. So we can customize the port. Let's go ahead and make our entry method. So the first thing we're going to do is pass the flags so we can actually use the port number. Let's go ahead and create the hub. So we're just going to let it import the server for us just like that. And we're using the new hub constructor. Let's go ahead and define the handler for our WebSocket connections. So this is just going to be a basic HTTP handle. And we're going to be listening on the /WS route. So when we connect to our game, we want to make sure we connect using the hostname and the port /WS. And the handler function for this route is going to be our hub's serve function. So we're going to need to take a writer and a request. We're just going to call hub.serve. And then we can pass in the handler that the hub expects, which is just going to be our clients.new WebSocket client, which is this method here. So we can readily pass in W and R. We're getting an error because it's saying that this kind of function is not what we're expecting from the hub serve method. So that's kind of strange. So we expect a function that takes in a pointer to the hub, a HTTP response writer, and a request pointer. And it should return a client interfacer and an error. Let's see, what is this? It takes in a pointer to the hub. It takes a pointer to a HTTP response writer. So let's go ahead and change that So it just takes the object. Yeah, we're not taking a pointer to a writer, we're just taking the writer object itself passed in by value. So once we fix that up, we see that this is satisfied. So basically now when a new WebSocket connection is created and someone tries to access the WS route, it will go ahead and serve that new connection with the hub and by creating a new WebSocket client to start processing those requests. So this is just defining the handler, but now we actually need to go ahead and run the hub. So we're going to do that in a Go routine just to make sure that this doesn't block, and then the hub can run in the background. We need to go ahead and actually start listening on this HTTP port. So we're going to go ahead and define our address that we want to listen on. We don't really care what host name the client uses to connect to us, but we do care that the port is going to be this from the command line. So by default, the port's just going to be 8080. And we're just going to go and try to listen and serve on this port. And finally, if we got an error, we're just going to go ahead and log a fatal message, which will stop the server and print out the error. Fatal F, print the error, and let's go ahead and put some more logging here as well. Cool. So that's everything we need. If we go ahead and press F5 now, we should be able to start listening on the server for connections. And this is kind of what I was talking about in the last video. If you're on Windows, it will ask you if you want to add a firewall exception. And this is just the name of the output that we're calling it. We've set this up in launch.json, so this is always going to be called debug.exe. So we can just allow this once and it shouldn't bother us again. So you can see here it says starting server on port 8080, awaiting client registrations. So we've actually now got our own WebSocket server up and running with Go, and the architecture is set up in such a way that it's going to be very easy for us to go ahead and connect to it and have a new client interfacer dedicated just for our connection to go ahead and continuously run a read pump and a write pump and process our messages. We've just set ourselves up to potentially perform lots of logic for broadcasting to the server or sending packets to different players and all of that kind of stuff that we're going to need for our game. And because these are just HTTP messages being processed and being turned into WebSocket connections, if I do just access http://localhost port 8080/ws, it should be listening on that route. So I should at least see some sort of like message or like maybe even a failure if I try to connect. So you can see here it says new client connected from my IP address, and it just says error obtaining client for new connection. WebSocket, the client's not using WebSocket protocols, so it couldn't update the request. But believe it or not, that's a good thing. That shows to us that at least the hub was dispatching a new client interfacer, which was then trying to actually upgrade the request. So this puts us in a really good position for when we start connecting with Godot, because we're actually going to be using genuine WebSocket connections to connect to our server and then start having the game logic run on the client and on the server. So this is a good place to stop for now. This brings us one step closer to creating a functional multiplayer game. So yeah, if you have any questions or feedback, I'd love to hear from you. Drop a comment below or leave a like on the video. And again, you should definitely join the Discord channel. This has other game devs online who are actively discussing the course, and we can work together to help solve problems, or if you need help, you can reach out on the Discord. So thanks a lot for watching, and I'll see you in the next part. Have a nice day.